For number 12, we have to expand the polynomial. So we will just FOIL out the x minus 3 times the x minus 3 and then distribute through by the x. So x minus 3 times x minus 3 is x squared minus 3x minus 3x plus 9. Combine the like terms, x squared minus 6x plus 9. Distribute through the x. X to the second times x is x to the third minus 6x squared plus 9x, plus 9x. Keep our y equals, and our function in standard form is y equals x to the third minus 6x squared plus 9x. Over here, I will begin by taking the x plus 4 and multiplying it by x plus 4. We can multiply in any order since multiplication is commutative, so I will carry along my x minus 1 and multiply out x plus 4 squared, which gives me x squared plus 8x plus 16. Now I will take my x and distribute it through every term in the second polynomial. So we'll do x times x squared gives you x to the third. X times 8x is a positive 8x squared. X times 16 is 16x. Now we'll continue and distribute the negative 1 through every term in the second polynomial. Negative 1 times x squared is negative x squared. Negative 1 times 8x is negative 8x. And negative 1 times 16 is negative 16. We can combine like terms. We'll have x to the third. We'll combine the 8x squared with the negative 1x squared for 7x squared. We'll take the 16x and the negative 8x, combine those to a positive 8x, and carry along the negative 16. And that is the function in standard form. Going on to number 14. This will be number 14 and number 15. 14 says determine the zeros and their multiplicity for the polynomial equation, leaving answers an exact value. So the first step we need to do to find zeros is to factor. So we can factor out a GCF. Every term has a 2 and an x in it, so we'll factor out the 2x. We'll be left with x to the second minus 6x plus 5. We can now factor the leftover quadratic. We need two factors of 5 that add to negative 6. The signs have to be the same, so we will use negative 1 and negative 5. So x minus 1 and x minus 5. Negative 1 times negative 5 gives us 5, and we add negative 1x and negative 5x, we get negative 6x. So the zeros, we set each factor to 0. X will equal 0 at this point, x equals 1, and x equals 5. Each one of these zeros occurs one time, so this has an odd multiplicity. This one also has an odd multiplicity, and this has an odd multiplicity, and the multiplicity is 1, multiplicity is 1, and the multiplicity is 1. Okay, over here, we can use substitution to factor this. The x to the second squared will end up being x to the fourth, so we can let u equal x to the second. So therefore u squared will be x to the fourth. So u squared minus 10u plus 16 will be our quadratic. We can then factor out u and u. We need factors of 16 that give us 10. How about 8 and 2? They need to be same signs. They both have to be negative since the middle term is negative. So u will equal 8 and u will equal 2. Now we have to solve for x for our zeros. Since u is x squared, we'll substitute back the x squared for the u. X squared is equal to 8 and x squared is equal to 2. To solve undoing a square, we're going to do the inverse operation of square root. So x will equal positive and negative 2 radical 2 if we reduce the radical, and x will equal positive and negative radical 2. Each one of these occurs at one time. Positive 2 radical 2 and negative 2 radical 2 are two different solutions. They only occur once each. Positive radical 2 and negative radical 2 again are one time each. Since each one of these factors has a multiplicity of 1, they all have an odd multiplicity.